I'm Ashana, here with my teammates Shweta, Himanshu, Sai to present Smart SONiC Monitoring System, adding smartness to guard everyday SONiC using machine learning. All knows SONiC with its containerized architecture, open source nature, and capability to run on switches from multiple vendors and ASIC is becoming network OS of choice. But with its large-scale deployment in data center, its continuous monitoring and maintenance is a challenge. Most end users are unaware of the issue that might happen in the switches, and when a system crashes with heavy technical log, it causes panic in them. End user also are not aware whether an issue needs to be escalated to the maintenance or it's fault at their end. So they just keep posting their errors with the technical team. End users are also not familiar with the severity of an issue unless a crash occurred, and this crash could have been avoided if the issue was escalated timely. Discuss the design prototype. The system runs in two parts. One is the log parser running in the SONiC device. And this parcel will run continuously and monitor for any critical error warning logs. These logs are then pre-processed and sent to the cloud server where log analyzer is being run in a JSON format. Here we are running two ML models. One ML model will predict the severity of the issue. Another ML model is used to predict the likely cause of the issue. Then this is redirected to SQL Server for their storage and to train again the ML model efficiently. And this data is then just presented to the user in a Grafana dashboard. Log parser will monitor for any error warning or critical code logs. Then it's pre-processed, and since the data is textual, it's converted into vector format using TF-IDF, and the feature dimension is high, so we have reduced it using PCA. Then we feed the data into two ML models. One model will predict the severity of an issue and mark it as critical and non-critical. Other will mark it as the likely cause of the issue in a user-friendly format. This data is then fed to SQL Server and visualized through Grafana dashboard.
Hi guys, this is the live demo. So this is our log parser file, which will take input as a syslog. So we have collected some logs. This will act as an input to log parser file. So we are just parsing it and we are storing it into the JSON format as per our requirement. If it is in error, warning, critical, then only we are writing it to the JSON format file. You can see the JSON format file. So these are the fields, 4 fields of the JSON format file. This will act as an input to log analyzer module. So in log analyzer module, we need to label the data so that we have stored it into the CSV. You can see the error message and the respective label non-critical or critical. This will act as an input to analyzer thing. In analyzer, first module is TF-IDF. So TF-IDF is basically the feature extractor which will give you the numerical vectorized format for the given data. So after calculation the TF-IDF, we are reducing the dimensionality using the PCA to 10. So the whatever the result, it will be act as a input to our model. So we are building two models, which are NV Gaussian and logistic regression model. So NV Gaussian is giving the more accuracy. You can see the NV Gaussian model accuracy is 80.95% and accuracy of logistic regression model is 61, which is very low. So we are, as we saw, like we have predicted the severity of a model as a critical or non-critical using the TF-IDF and NV Gaussian and logistic regression model. So we are using the same model for to predict the class of an issue. So we have divided the error into the 5 classes and we are using the same model. We already ran our program. You can see the accuracy of the NV Gaussian is 83 and accuracy of the logistic regression, which is also similar to the NV Gaussian. So we are giving the data to the dashboard also for visualization purpose. So here is the data. You can see the entry severity and issue are predicted by our model, and recommendation we are giving on based on.
This is the Smart SONiC monitoring dashboard. We have SONiC logs with containers, error codes, predicted severity, and recommendations. And then we have a cumulative display of container related issue count and the number of critical and non-critical issues. And then we have the device management dashboard. Any new SONiC device deployed in the user environment will be onboarded here. Device related information such as the status, memory, and CPU utilization, location will be updated over here.